So first thing, let's kind of talk through the program and the purpose of it. So it's rock, paper, scissors, right? But a couple added elements. So we have rock, paper, scissors, lizard twosies, and Spock. Okay? So, paper, let's see, beats rock. Let's see. And Spock. That's right, because it disproves Spock. Okay. Rock beats scissors. What else? Beat anything else? Yeah, it like crushes the lizard, bro. So I'm gonna put scissors beats what?
Decapitates lizard.
That's right. Paper and lizard.
Rock, paper, scissors.
Yeah, I got
Okay, oh,
rock
yeah,
beats
yeah.
lizard and lizard. And then we need lizard. What's the lizard? I think lizard like poisons Spock, right? Eats. And then it like eats the paper. So Spock and paper. And then the last one is, I think Spock vaporizes. It eats rock. What else? Okay, is that all of them? Okay. So when we think about this game, what are the steps? What's an algorithm we can think of? We're playing against a computer.
I mean, I found, at least for me, I found it easier to assign the values to an integer instead of like a string.
Assign value, spell that word. Values to it. In 2 weeks, no, next week, we're gonna learn about enumerators. And it's gonna be an easy way to do this. But for now, that's exactly right. That's the easiest way is assign it to an integer. Okay, so everything has an integer for both the player and the computer. What else? Let's talk through the game. If I was just gonna play with you, I would pick in my head. I'd pick what I was gonna do, right?
Mm-hmm.
And then the person I'm playing against would pick what they're gonna do. And then what? Pretty simple game. It's not nothing crazy, right? You compare based off one of these statements. So assign values to int. Step 2. So if I'm breaking that down, let's say player picks, computer picks, compare, and then that's gonna be like play again. Is there anything I'm missing? Anything I can like break down any further? Oh yeah, let's do it. So compare, I'll put like 4A output results. That's good. Okay, anything else? I think it's simple enough. It's not crazy. What makes it hard is the nestled, the syntax, right? Okay, So, how many of you use a bunch of if-else statements? How many of you use switch statements? Okay, I was going to say my third question is how many of you use both? Okay. So, first thing, let me walk you through what we've already have coded here. If you were at your job and you're taking legacy code that you needed to improve on or add to, it's really good to understand what you're doing, kind of understand the context of what's happening. Some of these things you haven't learned yet, some of these things you have, but hopefully you can understand a little bit. So these are our pre-processing directives, our include statements. This right here points to a header file, which I created. I don't know why, and I haven't graded anyone in this class yet, so sorry if I'm calling you out. I'm talking about my other class, though. A few people just decided to delete that. Like, I don't know what that is, I'm just going to delete it. Like, so don't delete things if you don't know what it does, okay? The IO stream, that we should know about that one already. String, we know about that one already. CTime, I actually don't think, depending on how you did your random code generator, you may or may not even need this. Just depends how you did it. But that gets the console's time. Okay, then we know what this is. Michael has like a heart attack every time he sees that statement. And then, okay, and then we have something called a function, which, fun fact, we're going to learn about functions this week. So it's kind of good to kind of get an idea of what's happening here. Every program, every homework assignment you've done so far has been within a function. And the reason why is because down here in that main driver code, which we talked about that first few weeks, I call the function, okay? The return type, so just like variables, functions need return types. So the return type of the game logic function is a string. That means it's going to return a string, which is going to be that output, right? And then it also takes a parameter. And the parameter is of type integer, and that's going to be the computer's choice. Because of that, you don't actually need to define that again. It's been defined here because that's what I'm passing into that function. Okay. Then we have a variable called result. That's string. Result is those statements. The Spock smashes scissors, things like that, is going to be stored in the result variable. And then play again. This is strictly for to capture a variable if you want to like repeat the game, if you want to play the game again. We following so far? Okay. Then we have our welcome. And then this is the first thing. Ask the player which option they will choose. I will say I'm going to code it so it works once through, and then I'm going to go back through to add logic to loop. So let's not worry about the play again stuff right now. Let's just get it working one time, and then we'll add it. So ask the player what option they will choose. How do we do that?
You do cout, and then type in, please choose rock, paper, scissors, move Spock, and then in parentheses, you have like a number to represent what integer will be assigned to that value.
Doesn't matter. You guys can kind of write whatever you want there, but something like that, right?
Yeah, and then you CN for the actual input of the player, and then that will equal the player choice.
C in player choice. Uh-oh. Don't have a player choice.
Yeah, I had to do this.
If I make one, yeah? Okay. So once you have your player choice, what if the player chooses 71?
You'll have to have like a default in there so it can say, hey, that's an invalid option. You choose 1, 2, 3.
How would you guys do that default option?
I did mine with a switch statement. I did case 1, 2, 3, 4, and 5, and then a default. So if it wasn't any of those, it would say invalid option.
Oh, so you mean like after this it just falls into the logic and then the default is?
That's what I did too.
That's cool. I dig that. So if they didn't put, yeah, I'm gonna go with that. I like that. What I did was I did a do while loop here. Just this right here was a do while, and it's like if the player choice wasn't one of the options, then make them choose again.
I haven't used Switch before, and so I just
Yeah.
wanted to try it out. So I used that.
I like that. That's good. Okay, so let's go with that. I like that. Generate a random number between 1 and 5 for the computer's selection. And whenever you have these to-dos, notice how I've indented it and I've put it within the scope of this if statement. Trust what I've done here. If that's what I've done, keep your logic inside of that. Just a little tip there. So there are different ways you can do random numbers. I talked about one of the ways last week. Someone throw out what you guys did.
I did like modulus 5 plus 1.
Oh, rand modulus 5 plus 1. Like that.
I don't know if the syntax is exactly like that. I don't remember what my syntax is off.
Okay.
But it worked. So.
Okay. Did anyone do something similar to that? Okay, walk me through it. What's the exact syntax here?
I think it was 1 plus and then rand and %5 in
You did 1 plus.
and then parentheses rand %5.
%5. Yeah, either way, that works. And then what am I doing with this output? Like where?
You want a second computer choice to that.
Beautiful. That. I think that is fantastic.
Do you not have to like input something before that to make the random work?
Like what?
Well, remember I asked last time if you have to put like srand and then unsigned and then time and null.
Like something like that?
Yeah.
Yeah, so srand is what sets the seed.
Okay.
So correct me if I'm wrong, Michael, this srand right here will make it so it's always one number, right? Or isn't the seed just whatever the time is?
Right, take the time and puts that as the seed, so you get a huge number for it to randomize against.
Yeah, so this makes it a little bit more robust. It takes the time and sets the seed to be whatever that is. So it makes it a little bit more random. Because remember, random, there's no such thing as truly random, but if we can do some logic to make it a little bit more robust, that'll be good.
The more unique and larger your seed is, the mathematical algorithm to make random numbers,
Yeah.
it makes them more random.
So you don't have to put it, but your game would probably be not as fun, a little bit more predictable if you didn't.
This is probably why I ran into issues, because I changed it from computer choice to random choice.
Mm.
Ran parentheses, and then outside of those parentheses, I did modulus 5 plus 1. And then
Gotcha. Okay. So, and now the reason why this is important here is because if computer choice is equal to 0, I'm passing in a 0 here.
Yeah.
So that's
I put
why,
that up top, I did int random choice equals 0.
like in here.
Is equal to.
Or
no,
like
I
you just
did
mean in-
below. I did below play again.
Gotcha.
I said int random choice.
Gotcha. Okay. So now we're using the switch statements or the if statements or a combination to actually do our step, I guess it would be step 3, right? No, step 4, where we're doing our conditions. So once again, let's ignore all this right now. This is all the play again stuff. I think it's what most of you guys ran into this problem right here. So let's take a look. So this is where it gets a little confusing. The player needs to pick their choice, which they've done. The computer needs to pick their choice, which they've done. But you now have, I think, if I'm not mistaken, 25 different combinations that could happen. Because you have 5 options for the player, and you have 5 options for the computer. And each one of those combinations, there needs to be an interaction. There needs to be some sort of statement. So how can we use some sort of control statement to pick between what the player could choose. Does that make sense? There's 5 different potential things the player could do. How would we do that?
I did 5 if-else statements. I don't know if this is the best way to do it, but I did 5 more in each one of those for all different computer
Okay.
choices.
If-else statements are totally fine. Do you know what my personal rule of thumb is? If I have to do more than like 2 different combinations, I usually just go with a switch. A switch statement is an if-else statement. It's just more compact syntax, and so it handles a lot more branches a little bit cleaner. There's not, as far as I know, there's not like this a huge computational difference or anything like that. It's just for readability. So my personal opinion is I do a switch statement, but if you guys did an if-else statement, that totally is fine. The syntax, and I'm going to do switch statement also because you guys are probably a little bit less familiar with the syntax. So I'm going to put it here. So with a switch statement, and this is what me and Michael were talking about last week, inside the parameter here, you need to put what is it switching against. Now, it's not like an if statement. You can't put like if player choice is this, that, or the other. It has to be, I think the compiler was something like it has to be an integral or a numerator type, something fancy. Basically, it needs to be a solid statement, whether that's a string or an integer. It needs to be a match. Does it match this thing, right? So what are we switching against?
Player.
Player choice, right? So switch player choice, and then you can start with your curly brackets here. So now you do your different cases. And remember, we assign numbers, right? We have 1 through 5. So case 1, so if they chose 1, and then we put a colon here, and then we space, tab, and now we need to put the logic. If the player chose 1, we said 1 was rock. Okay, so we're talking about rock here. But now we have to think, okay, the player chose something. Now, how many different possible things could the computer have chosen? 5 different things. So now we're saying player's rock, computer could be one of 5 different things. One of 5 different things sounds like another switch statement or if-else statement. So now I would do switch again. But this time, what are we switching? Computer choice.
Here's this may be something we won't talk about yet, but since all of them have at least one thing equals something else, before the switch statement, I put a computer choice equal to player choice at the top, and then break.
All right.
You have to do that one in every single.
Talk me through that.
So above the switch.
Above the player choice switch?
Before the switch,
Okay.
if parent computer choice equal to player choice and parent open curlies result equal or assigned to, it's a tie.
You lost me.
Okay. Where are you? Okay. Equal to, double equals,
Yeah.
player choice,
Okay.
and then your standard if curly braces,
Yep.
and then the next thing is result,
It's a tie.
Yep.
assigned to, it's a tie,
That's what I used.
I like that.
I did that too.
That is really clean.
and then see out,
And then put it's a tie, right?
yep, no, result,
Oh yeah. Doy.
and then break,
And then the curly braces, right?
no, break after.
Oh yeah.
So I did
Yep.
that, so I didn't have to have at least one statement in the. Well, mine worked. Oh, you don't have a loop yet.
Yeah.
The break.
Oh yeah. That's right. Because we'd be looping through the game logic.
So that way you.
Perfect.
Have 4 choices in your case of 5.
Perfect. Okay. I am gonna put an endl here.
Yeah.
So, so now we're player is rock, computer. Now we're on computer. Case 1 would be if they're also a rock, but now we don't have to code that. That's what you're saying, right? So you just go straight to case 2.
Yep.
Okay. So if player is rock and computer is, does someone want to pull up the numbers that they have so I don't have to keep?
2 is paper,
Okay, 2 is paper.
3 is scissors,
So
Very dollars.
you know what? I'm just gonna cheat off mine. I just realized.
If we fix our code, is it okay if we turn it in late?
Why would you do that?
Fixing it.
We'll talk about it. We'll talk about what to do about that. You should fix it for your own good, though. So according to the syllabus, you have one late assignment you can turn in for up to full credit. The second assignment is like 75%. The third one is 50%. So you can and you will get full credit this time, but probably not next time. You'll get up to 75% credit. Okay, so paper covers are, and then for it to pass the test statements, I have it spelled exactly like this, right? Okay, so then I'm gonna cheat a little because this is a little redundant. It's not hard, it's just a lot of typing. So we're just gonna walk through each one. So case 3, rock crushes scissors, right? Case 4, rock crushes lizard. Case 5, Spock vaporizes rock. And you notice that depending on what it is, you either win or you lose, right? Okay, that was all just case 1 of the player. And we had to iterate through each of the cases there. So you can imagine that it gets a little messy, right? So this would be that would be that switch statement. So what I would do is I would say break to break out of this first case 1, okay? So now we are case 2 for the player, which was paper, right?
yeah.
And so if it's case 2 for paper, we're gonna do another switch for the computer choice. And I'm gonna cheat. Maybe. And we'll just talk through it. So, computer choice. So player has paper. They have rock. You win. We don't need this anymore. Right? Because that's the tie statement. 3, scissors cut paper. 4, lizards eat paper, I guess. 5, paper disproves Spock. We following so far? So what would the next thing we need to do be? Oh my gosh. Case 3. Go back in indentation. Indentation is important as far as readability goes. It's not important as far as your code will still work. One of my coworkers, he got his software engineering degree at UVU, and he said his first homework assignment, one of the students wrote their entire program on one line because I thought it would be more efficient, like for the computer. And that's when they had a long talk about, no, it's for readability. It still worked, but that's horrible for debugging and everything else. So when I say it's really important, I mean it's really important, but I don't mean that your code will not work if your indentation sucks. But just find your style and be consistent with it.
That's because it's just reading across,
Yeah,
right?
it's just reading it. That's
So
right.
when you do that, you have a bug, it tells you it's on line 1.
Yeah, that's true. My bugs are always on line 1. It's crazy. Okay. So now I have to be really careful and make sure I'm like copying the right stuff here.
Yeah,
So
this part is fairly tedious.
it's tedious, huh? And as you guys get more well versed with C++, you might find way better ways to do this. This is the old-fashioned control statement way. Have any of you guys ever played the game Undertale?
No, not yet.
Do you guys know the trick about Undertale?
Uh-uh.
Okay, so Undertale is a little indie game that's like game of the year Really, really fantastic game. It's a really simple, like pixel art game. And Undertale, the entire game logic is one giant if-else statement like this.
What?
The entire logic is coded absolutely horrendously. But it just shows, like, you can get it done. I mean, it's a great game. Like, he achieved his purpose, right? He built a working game that's fantastic.
What did you code it in?
I can't remember. It might have been C++ or C# even. But anyway, just know you always want to make your code better. But and this is a problem you will forever run into, is the trap of over engineering. I'm OCD. I'm a perfectionist. I could go back to my projects over and over and over for the rest of time to make them better and better and better. You need to look at the trade-off between making it good and readable and efficient and easy enough for someone to go back and debug, but you don't want to put more time into it than what it's worth, right? If it achieves its purpose, if it's already doing its thing, you should probably leave it alone too. Sometimes your programs are like Jenga, where it's like, I don't know why it's working, but it's working. I don't want to touch it. Just kidding. You don't want to do that. But
One of the things that I've seen in my career is people being clever.
yeah,
They get to use the language really well, and they put cryptic things in. And yeah, you're worried about the next guy. Usually they come back after 2 years and they don't understand it.
yeah.
And so I have a picture at my desk that said, when I wrote this code, only God and I understood what it does. Now it says, now only God knows.
Okay. All right, you got me on a tangent here. This is still important stuff. Okay. I, at work, used to code, and I've explained this before, code in a language called BASIC, or Unibasic, technically, which is a flavor of BASIC, which was the language of the 80s. So, there was a programmer, and now I'm not trying to bag on this guy because I have feeling the shoes of many, many talented programmers. But I am gonna bag on this coding practice he did. So he would have a program. Remember I told you one of our sales programs was like 10,000 lines of code. So we're not talking like this. We're talking thousands of lines of code. And let's say he needed to debug something or he needed to add something. The very first thing he would do is he would say, if Inkle, like that. Inkle was a variable that he put at the top.
Oh, yeah.
You know where I'm going with this?
I do.
He would set it to like 1 or something. He'd say if Inkle, and I'm gonna put C++ logic kind of so you kind of see, and then he would have hundreds of lines of code. Everything he was doing for that project, he would put in that if statement. And then what he would do is he would test it. If Inkle's 1, so if it exists, run my change. If it's 0, then go back to how it was before I did my change. That sounds smart. But the problem is when I'm looking at 10,000 lines of code, and I don't know what's in production, what's not in production. Did he forget to set his flag off? It was just absolutely horrendous. And so the joke at work is, don't do the Inkles. No Inkle defs. And so the good practice thing that he should have done, because you don't want to delete your code either, right? That's not good practice either. You want to do like a little comment. Just comment it out, right? If you don't want to delete your old code, just comment it out. It's not going anywhere. And then, like over time, we can do a cleanup. And once it's been kind of trued and tested, or even better, if you're using some sort of like GitHub or some sort of repository thing, you can always roll back your changes. But just good coding practice is no equals. Don't do that.
So, do we talk about macros or pre-processing?
Not really. We don't really.
So there's a way to do that with pre-processing.
Oh, really?
Much nicer
In C++?
than C++.
That's cool. Yeah, we don't get into that. All right. So now we're on case 3, which was something. Scissors. Okay. So scissors. Player is scissors. Computer is rock. Scissors and paper. We don't need this one anymore, right? Because that's the tie statement. Scissors, Spock. Okay, so now what we do is we break, and now we're on the next case, which is what? 4, right?
That's a lizard.
Lizard. Okay, so players on lizard, computers on rock, computers on paper, computers on scissors. We don't need a tie anymore. Lizard poisons Spock. Okay. Then we need to do our break. Keep doing that. It's annoying. And now what case are we on? Case 5, which is Spock. So, since we're learning about functions this week,
Real quick, here's,
what?
I know it's not necessary in these switch statements, but I've been taught in read a certain way to have default statements
Default at the end, right?
at the end regardless, so
Yep.
good habit.
Yep, absolutely. And in this case, the way we've coded it, we need to have it because of the way we've coded your choice, right? So talk me through that, Taden. So we've gone through the 5 choices that the player could make, but what if they typed in something like 91?
Is the default like not equal to 5? How did not? I mean, is how did I type that? I'm gonna go back.
You're good. So,
Default. I just did default because it.
oh, you just wrote
I
default?
wrote default and then put C out and dollar option please type 1, 2, 3, 4, or 5 because if it's gonna match 1 through 5, it'll hit one of the cases. But if it doesn't hit any of them, then it'll go to default, and so you don't have to specify anything.
Yep, that's exactly how a default works. So invalid option. Please choose, I don't know, 1 through 5, something like that. And Michael brings up a good point. It's good coding practice to always have a default. I can't remember, it was last week's assignment. I can't remember what we were working on. But one of you asked me a question why I had an else statement at the end. And it was for that same reason. It's a catch-all. What you don't want in programming is you don't want your variables or you don't want your conditions to kind of like go down a path and get lost. They kind of don't go anywhere. That makes debugging really hard. If you can always lead it somewhere and then have some sort of statement or some sort of like error log or whatever, so you're tracking like where did it go. So it helps with debugging. So in this case, that's great because we know any potential input the player could put is now covered, and it's gonna hit something. If anything, it's gonna hit an invalid option.
It's also security.
Yep. Oh, security.
Secure code, you always know when that works.
Yep, that's smart. Okay, so we're not quite done yet because of all this stuff, and this is, I think, what a lot of people are running into. In fact, this looks identical to what some of you are running into, huh? Because we have this thing, and it's like, I don't know what this is, this return result, and then you blamed it on me because you said this is the code that I wrote. It's my fault. Just kidding. Luis specifically said that.
I didn't phrase it.
Yeah. So before I get to that, I kind of want to talk. I want you guys to start thinking about efficiency now. And especially with functions, because that's what we're learning. Think about how many times you have to repeat code. So, granted, it was a little different, but we've pretty much had to write this switch statement 5 times. With little variances. So when I see things like that, alarm bells are immediately going off in my head, and I'm thinking, is there a function I can write where I only have to write this like 1 time, and then I just call that function each time? And I haven't worked it through in my head. This is all just kind of like vague. Yeah, go ahead.
That's actually what I did on mine.
That's what you did? That's perfect. Yeah, so I haven't quite worked through, maybe you can talk me through it, but I'm thinking something like, if we wrote a function that was like player choice or whatever, and then passed it in a parameter based on whatever they did, it would kind of output exactly what it was. That would be the best way. How did you do it in yours?
So I made, I think it was 3 separate functions. Let me pull it back up. Yeah, I had one to transfer the numbers back into text. I had one to do the thematic, like their text of rock crushes, like those little keywords, crushes, vaporizes, crushes,
Yeah.
etc. And then one to decide who was the winner. And so it would go through and then first check who would win. Well, first it checks if it's a tie, then who wins, computer or player. Then it would go through just a really short
Yeah.
if statement to say, all right, if winner is this, and
Yeah.
loser is this, display this.
That's beautiful. That's really, really good.
And then at the end of each of those, it would say, display result for win, lose, check.
Perfect.
So it would say either you win or you lose.
Yeah, that's great. So I encourage you guys to think about that going forward. Think about how you can consolidate so you only have to, like I said, programmers are lazy. We're a lazy bunch, right? Not really, but we're efficient. We try to think, what can I do to automate this? And in this case, this is prime for making a function or two functions or, something like that. So just keep that in mind. Okay, back to this thing. This is where you have to kind of get in professor's head a little bit, and so I apologize for that. The first thing that I did is, well, we have this do while loop that I already did for you, and it's just asking, would you like to play again, yes or no? If you hit, let's see, if you want to play again, or if you don't hit the right thing, it's just going to keep asking you. Right here, notice that this is a do while loop as well. So if it's equal to 1, then what are we going to do? We're going to keep running, right? And so I already had half of it for you. If it's equal to 1, we're going to do all of this again. If it's equal to 2, we're done. And if it's not 1 or a 2, this was my approach to how to handle with statements that aren't what you're asking for. So it's just going to keep asking you, so if you put 7, it'll be like, do you want to play again? 8, do you want to play again? 9, do you want to play again? And then if you put 1 or a 2, then it'll be done. If you hit a 1, it's going to repeat the whole thing again. So that's why things are off right here, is because it's missing the do part of the while. This right here is the return statement, and we're going to learn about this week. With functions, you need, unless it's a void, we'll learn, you need a return statement. You need to say what is the function giving back? And I've already done that. And the reason why I need this is because I'm actually feeding that result into my test program. And then every function needs an end for the curly brace. So this right here is the end of the function. This right here is where you need to figure out where you're going to put your loop. Now, what's cool about Visual Studio Code, and I'd imagine Visual Studio and pretty much any other IDE or code editor, notice how every time I've indented, it has these lines. This kind of tells you the scope of everything. And this is for us to kind of see where we're at. So if this is the scope of the do while loop, what I can do is I can actually follow this line all the way up. And now it's on this indentation is actually where I would put that do statement, and everything else would fall under that. Does that make sense? So thinking about what we've coded, what needs to be in that loop?
Player choice and below.
Player choice and below, like right here. So it would be on this line, right?
Above that, where you have is player choice.
Oh, I see what you're saying. Right here.
Yep.
Right here, put smash the scissors. Right here, you put
And VS Code's trying to be smart and autofill for us, but we don't need it.
wants a spot, crushes, scissors.
Does that make sense? So now that all of this is in that do while loop, all of this is going to repeat multiple times as long as play again equals 1. And then when it's all done, we're gonna return result. I only need the information for one game, so that's why you don't need to like, keep populating that.
That's where I got confused, 'cause I kept like, my code was the same, but I thought it was like supposed to like work pretty much. I didn't know I had to add and do. So I kept, like, I had to keep like restarting the program.
Like, what's going on?
Trying it again.
Yeah.
So I eventually just like, kinda like moved all the tabs, and then it stopped giving me an error.
You're like,
I'm done.
it's the Jenga tower, dude.
Yeah.
It's like,
I said, I'm done, I won't like play it again, I just have
Right.
to open it again, but that makes more sense.
so this is the next thing I want to show you. And this is where I'm on the pendulum of like code it how you want versus pass my test cases. It's not like my test cases are necessarily a mystery. I give you the program to run and it shows you how you're wrong. And so if it is something as silly as the verbiage being different, it will say you put your verbiage like this. I expected it to be like this. And you can literally just copy and paste it and it should satisfy it. So I'm gonna push play and I'm gonna go test. And we passed them all. We did it. And what I noticed, and I did take it easy. Like I said, I haven't graded your guys' yet, but my other class, I was taking it easy where if it said test 4 failed, and it said you put rock smashes lizard, it's supposed to be rock crushes lizard or something. I've been like, okay, well, you did it. But once again, the other side of me is like, technically didn't follow instructions either. So it's like, what's up?
I copied your thing.
And it does that, huh? In the PDF, right?
Well, no, the note says Spock smashes scissors, but your code wants Spock crushes scissors.
Okay. Yeah, did you catch that? Well, thank you. But anyway, regardless, if you run the test program, you should see.
Finally got it working. Oh,
There you go. There you go.
now I can think-
So you guys were the judge and jury on this one. I'm gonna take it easy, and I'm gonna progressively get a little bit harder as we go through the semester. But I am gonna hold you to the standard to pass the test cases. Make sure you're doing that you're passing them. If you're not passing them, and let's say it's like you, Tayden, you're like it works, it's just not passing it. Reach out to me before the due date, and we can work out why. Because at that point, it's like, well, yeah, you're doing it. Let's just kind of get you on the right path. But any questions on anything? Perfect. All right. I'm gonna pause my recording.